But this is a pretty big casting. It's pretty.
Is this?
It's not as big as that one.
So is this like 8,000 tons?
No, this is actually a 6,500 ton. The rear,
Are you kidding me?
The rear is 9,000 tons. Yeah.
How? Okay, so how
It's
did
just
you
about
keep it
flow,
together?
right? Like you gotta, like when you think about tonnage, it's about how much metal you're moving within the platen size and how fast you're moving it. But you can restrict that metal flow by like making bad, feeds in bad directions. But when you look at the side, the flow, the biscuit comes in through the middle there.
Yeah.
And then we flow it all out and we do it like a river because like liquid metal wants to move like a river. A lot of times when you see these people copying us, and maybe I'm giving it away stuff, but it's an engineer drew it, right? And they drew triangles and trusses. Great. But here at Tesla, we have in-house die designers that sit right next to the guys that are designing the castings, and they're going back and forth in simulations so that we can lower the tonnage of the presses we're using by integrating the design of the part into the design of the tool, which is why we don't need necessarily 8,000 ton press for the front. When we started, we thought we would. We said, oh, we're gonna need 8,000 tons. But we worked through the team and we actually can make this front one on the same equipment as we make Model Ys.
That's,
not the rear one.
That's amazing.
The rear one's too big.
Yeah, well.
Helps with cycle time too, right?
Yeah, it does help the cycle time because you get more even cooling across the whole thing.
Well, that's the big thing, cooling and warpage. Everybody asks the same question. I mean, how much does this warp? And I said, well, it happens so quickly, it shouldn't warp at all. But
yeah, I mean, it's really about how long we cool it in the die and you let the skin cool, and then when you pull it out, we don't have straighteners or anything.
So how many presses are pushing these out now?
We have one for the front, two for the rear. But as I said, we have the Model Y ones.
Yeah.
So we have four of those. We can swap the die out. But we only need two, cycle times are down enough to make, 5,000. We only need two presses, one for front and one for rear.
Do you bother with backup tooling then?
Yeah, we swap the tools out.
Three sets of die?
At least two.
In a recent interview with Munro, the lead design team at Tesla revealed a startling revelation about the Cybertruck. So what's the big deal? It's all about Lars Moore's unexpected revelation, which may have gone unnoticed, but is crucial to Tesla's manufacturing prowess in a world where innovation reigns supreme. Get ready to delve deeply into the world of automotive innovation. Tesla has demonstrated its mettle watch this space as we examine how Tesla is differentiating itself in the race to produce hundreds of thousands of cars a year with its groundbreaking approach to casting backup tooling and production numbers. But that's not all. We'll also talk about how this revelation could send shockwaves through the automotive industry, possibly stopping even the formidable Ford F-150 Lightning in its tracks. Watch this thrilling episode without fail, but before you do, be sure you click the like and subscribe buttons. Welcome to Tesla Stock News. Let's get into the specifics of this groundbreaking revelation from Munro's recent discussion with the Tesla lead design team about the Cybertruck. Let's explore this noteworthy revelation made by Lars Moravi, which seems to have gone unnoticed for a while. When Lars Moravi said that they could produce the front Giga casting using the same size press as the one used for the Model Y Giga castings, it caught everyone's attention. Munro also exclaimed that this revelation underscores Tesla's remarkable capabilities, not only in terms of their assembly line workers, but also in terms of their design engineers. Their ability to quickly iterate surpassing the legacy car makers. The majority of you are likely aware that the Giga casting weighs 6,500 tons for the front and 9,000 tons for the rear. What's interesting about this casting, though, is how Tesla controls the metal flow, which is similar to the flow of a river, in contrast to previous attempts where engineers simply sketched designs using triangles and trusses. Tesla's in-house die designers collaborate closely with casting designers to create simulations that optimize part designs in order to minimize the amount of press tonnage needed. Surprisingly, they can use the same machinery for the front casting as for the Model Y, demonstrating their innovation and efficiency. However, the rear casting is still too big for this shared approach. This innovation affects cycle time as well as tonnage, resulting in more even cooling throughout the casting. Addressing concerns about warping, they've achieved rapid cooling without the need for straighteners at present. They have one press for the front and two for the rear alongside Model Y presses. Nevertheless, due to reduced cycle times, only two presses are necessary to produce 5,000 units daily. This revelation underscores Tesla's groundbreaking approach to manufacturing and design, setting them apart from the conventional automotive industry. It's yet another testament to their ability to revolutionize the industry. Do they have backup tooling? Indeed, they do. Sandy asked about it, and it turns out they maintain 3 sets of dices, while at least 2 are in use at any given time. If they're running one, they keep another as a backup, and they're able to rework the idle die while the other 2 are in operation. This precaution is necessary because when casting machines break down, they do so abruptly and without warning. To keep the production line running smoothly, they must swiftly replace the tools. You might be wondering why they need these backup dices. They always have backup dies on hand, or, as Lars put it, they recycle them, continuously rotating and maintaining the dies to ensure seamless production. Lars explained that this is important because when a casting machine breaks down, it can have serious consequences for production. It's a race against time to remove the faulty tool and insert a new one promptly. The goal is to ensure seamless production. Sandy first inquired as to whether the Cybertruck's front Giga casting machine was an 800-ton one. This revelation holds significance because it means the Cybertruck's production process takes up less space and operates more efficiently. It's like having a 2-bedroom house instead of a 3-bedroom one, a compact and efficient setup. Lars quickly corrected her, saying that it was a 60,000 machine, the same size as the one used for the Model Y. Furthermore, Lars mentioned that they have multiple Model Y machines in the factory, allowing them to utilize those machines for the casting. Has beautiful wavy lines running through it. These lines aren't just for show. Without them, the casting wouldn't have the rigidity needed to withstand the weight and torque demands made of it. Tesla has achieved a remarkably smooth design with raised ridges that offer an unobstructed path for the liquid metal to flow through. Traditionally, the approach would involve constructing the design with a complex network of triangles and meshes, much like creating a 3D animated character. However, all those triangles and meshes acted as barriers impeding the flow of the metal. Rapid homogeneous flow is ensured by an innovative technique, which prevents flaws or blobs in the casting. As the metal cools, its crystalline structure becomes incredibly durable and solid. The development of SpaceX has greatly benefited from the expertise that Tesla's material science team frequently shares with the company. A unique aluminum alloy with the perfect characteristics, smooth flow at high temperatures, quick cooling, and a robust crystal structure when solid, achieves an efficient and successful casting process. However, what distinguishes Tesla from its competitors is their ability to seamlessly integrate the casting design into the machine's design, which produces the product. This kind of synergy is the cornerstone of their success, even though anyone can build a prototype. When using traditional manufacturing methods, which involve many stamped parts that must be welded together, a number of challenges arise, including managing a multitude of parts and deploying a plethora of robots. Additionally, there are alignment issues as these disparate parts come together at the final assembly stage, sometimes requiring forceful interventions like wielding sledgehammers. However, Tesla's real challenge lies in mass production. They have mastered the art of efficiency, and due to all of these obstacles, production costs go up, efficiency goes down, and more labor is needed to make sure everything fits perfectly. The end product may not be as flawless as a car made by Giga casting. This method best represents the first principle mindset, which holds that the objective should be to construct cars as efficiently as possible. Furthermore, there is a significant topic of safety throughout the interview, a subject that many people are concerned about with the Cybertruck. These Giga castings are essential for addressing safety issues. They include particular during one-on-one conversations with a factory engineer. It became evident that the motor and batteries had been cleverly designed to slide out of harm's way in the event of a collision. The motor drops below the batteries, reducing the risk of injury. Additionally, the transition to steer-by-wire eliminates the traditional steering column, eliminating a significant safety hazard. Crush zones are strategically located at the front and rear of the vehicle. As impact occurs, these zones absorb the force, allowing the structure to collapse predictably and protect the occupants. When paired with the Giga casting's built-in safety systems, the Cybertruck's potential to penetrate the cabin during a collision makes it a serious contender for high safety ratings. Now, let's look at the production figures that Lars mentioned. He suggested that Tesla should aim to produce 5,000 Cybertrucks per week, which would include both the front and rear Giga castings. Taking into account some downtime throughout the year and assuming 50 weeks of active production, this works out to an impressive 50,000 Cybertrucks annually. However, it's important to keep in mind that Tesla may be underestimating its capabilities, as they could have 2 production lines and an additional 4 Model Y presses for the front Giga casting. As a result, they could easily surpass this target. The real obstacle right now appears to be the availability of the 90,000-ton Giga press for the rear casting. If both presses run simultaneously, production rates could potentially reach 7,500 units per week, exceeding the initial projection. Let's assume an average of 7,500 units per week, which would push their yearly production up into the range of 300,000 to 350,000 Cybertrucks instead of the initially projected 250,000. Sometimes they're hitting the mark at 10,000 units per week, but every now and then they have to take one out of service for maintenance. The rumors that they may already have a second Cybertruck production line up and running in addition to the one we've seen indicate that once they reach full-scale production, Tesla could potentially be producing well over 250,000 of these vehicles annually. What's even more intriguing is the alignment with Joe's flyovers and recent Cybertruck deliveries. Yes, people are actually then at will in 2024. This should send shippers down Ford's spine because its F-Series trucks are the company's lifeblood and have been the top-selling vehicles in the US for decades. So, that's it for this video. What are your thoughts on all these recent developments? Please share your opinions in the space provided for comments below. If you liked the video, don't forget to hit the like and subscribe buttons. We appreciate your time and hope to see you in our upcoming videos.